kind of like the used car sale of the world in a way. We really, really like to oversell our capabilities. So here at the University of Vermont, we have a unmanned aircraft systems team. We got some funding from U.S. Department of Transportation a number of years ago to get going in this field and to research really the capabilities and limitations of UAS technology, unmanned aircraft systems technology. And it's important that when we're talking about drones, we think about the difference between the platform and the sensor. And we often kind of lump these things together, but really it's different, and these all have different capabilities and limitations. On the platform side, we can generally group these things into fixed wings and quadcopters, and then on the sensor side, we've got a broad range of sensors, everything from really, not very fancy RGB cameras to now we're seeing people put LiDAR and thermal sensors on their drones. Because we've got a GIS crowd here, I'm really going to focus on drones from a mapping perspective, and thus I'm going to drill into a lot of the projects that we've been doing using fixed wing systems, which are really ideal for mapping. So these are systems in which we're doing detailed flight planning, and really our goal is to develop mapping grade products. Okay, so a little bit different than flying around and taking video of your wedding, or you doing some cool skateboarding moves or what have you. And in focusing on these, I'm talking about lightweight drones. Okay, we're not talking about Predators, Reapers, Global Hawks, these DoD systems. And that's really because in these situations, once you get to a certain size with drones, it's really not worth using a drone, right? As soon as you need a runway, you might as well go to traditional manned aircraft, because the regulations are such with drones regarding flight time, the ceiling, the line of sight, all of those things. You're better off using traditional manned aircraft. So we're talking about small, lightweight, battery-powered systems that are generally good for mapping some small areas. So like I meant, the focus of these types of systems and the work that we do is to do precision mapping, or at least accurate mapping to some scale. So this involves a few steps. The first is flight planning. So we're flying flight lines just as we would. We're doing flight operations, actually launching the drones up in the sky. And of course, what's interesting about a lot of these drones nowadays, even some of the quadcopters, your DJI Phantoms, if you own those, is you can pre-program them. And that's what we do. We pre-program them to execute a certain flight plan. So we're specifying things like the amount of overlap between images. We're specifying the altitude. We're talking about the area that we want to fly. And so once they're in the sky, these things are autonomous. And really the user, the operator, is not having a great deal of interaction with the drone. The drone is doing its thing, and we're waiting for it to come back and come in and land. And what we're talking about is gathering, regardless of the sensor, really, typically hundreds of images out there. So using cameras, we can gather hundreds of images, and just like a statewide orthophoto project, only on a much smaller area. And then using digital photogrammetric processing to bring all these images together. Okay, so here we're looking at a flight in which we've got all these little dots there representing a photo. There's about 60 to 70% overlap between these images, so any location on the ground, if we go to a digital photogrammetry view, any location on the ground is going to have 5, 10, maybe even over a dozen photos contributing to that location. So we're flying with a high degree of overlap, and we need to do this because in order to remove the distortions associated with the image collection, both with the terrain and the sensor, we need to have a 3D model, right? And we generate a 3D model as part of the digital photogrammetric process. And what we end up with are really sort of two general products. On one hand, we're talking about an orthophoto. There you see one in the lower left in ArcGIS Pro. And then up in the right there, loaded in QuickTrain Mod, there you see a point cloud, right? And we can generate, of course, various products from that. Those could be rasterized surface models, contours, etc. And I think what's really exciting is, although we're not using LiDAR for these sensors, although you can put LiDAR on drones, the downside of that is right now is LiDAR is really heavy, which means your drone is heavy, which means you can map small areas because you've got not a lot of battery life and they're really expensive. So if we focus on some of these more accessible drones, I think what's really cool is the photogrammetric processing, that is the process of stitching these images together and deriving additional products, has really advanced in the last few years. If you look at companies, we're big fans of Pix4D, but there's other companies like Agisoft or OpenDroneMap out there, even some online solutions like Drone Deploy will allow you to generate products. So this is a flight that we've done here in Burlington for one of our parks that was undergoing some renovations. So you can see we've got orthorectified over there on the left. In the center there, we've got a digital surface model as a true 3D representation of the features above ground. So you notice it does not do a good job of capturing those trees that didn't have leaves, but we can do some really nice filtering with it. And over on the right there, you've got a digital elevation model. And I think given the fact that this is not LiDAR, right, we don't have a laser penetrating and hitting things off the ground. Pretty amazing the quality of that digital elevation model. You see some divots there in the shadowed areas where the trees look like they're leaning, because those are the shadows from the deciduous trees, but still I think amazing quality for essentially a flying piece of styrofoam and a camera. All right, so one of the big advantages we like of drones is the resolution, of course. The fact that we can go out and generate both high spatial resolution data, but also the temporal resolution. So you're looking right now at some pixels. This is 30 meter by 30 meter Landsat pixels. This is Shelburne Bay in Vermont. If we go ahead and look at the UAS imagery, we really see the improvement there. And the key strength of UAS here is not only can we gather high resolution images at different times, this is orthorectified images. So here we are at the high water mark during flood stage for the lake. We can go back at the low water mark. And so for mapping these areas with great detail, right? You can imagine how long it would take a field crew to go out there and map the high water mark, or how expensive it would be to do this from high resolution satellite imagery or manned aircraft to generate similar accurate geospatial products. With UAS, that becomes a lot cheaper. Here we've got a dam survey going on. This is a large area in Pittsburgh, New Hampshire. Over on the left there you see the UAS imagery, and then over on the right there the Esri base map imagery. So higher spatial resolution, and also if you're interested in things like analyzing the condition of that spillway, the number of woody debris in there, UAS imagery really comes through. Particularly when we're talking about disaster response activities, especially those local scale ones. So when we're talking about things like the flooding in Houston and Florida, you know, NOAA, Army Corps of Engineers, right, all the big dogs are out there with their sensors flying, and they're getting that stuff up on web maps really quick. UAS have a role to play out there, certainly, but really where I think they play a role in local disaster management is the acquisition of geospatial data for local scale disasters. Those where FEMA is not showing up, NOAA is not flying their planes, right? There's not going to be millions and billions of dollars for geospatial acquisitions. You've got a flood on the local road. One of the nice things is, not only can you map the floods, but you can do collection over time. So here we're looking at a series of color infrared images. Over on the left there in March, you can see we've got ice conditions. April 9th, the ice has melted. And by April 16th, we've got the runoff coming down from the mountains, so we've got the flood conditions. So maybe we're thinking about redesigning this road in the future. Now we can have a really precise and accurate mapping of where the high water levels are. Something would be difficult to do with field crews alone, and extremely challenging to do with satellites given the timing of this, and then expensive to do with traditional manned aircraft. We can also derive three-dimensional data from this, right? So here's an example of a contaminated soil pile we had in Burlington, Vermont. We can go out there, do a 7-minute flight. We can gather orthorectified imagery, and then we can build 3D models, and we can, even though we don't have LiDAR data, you know, we cannot see through that soil pile, but given that it's on a relatively flat surface, we can simply shoot a plane through that and do some quick volume calculations. So this is really useful in those cases where you may not have access to something like an expensive ground-based LiDAR sensor. You may not have the time to set that up, or the area is inaccessible. Digital photogrammetric processing can generally get you within 2 to 5% in these areas, so pretty darn accurate. For a lot of projects, I think UAS kind of fall in a nice to have, right? So if you're with an engineering company, quite often you folks are producing maps like this. Not the world's best cartographer, but I do always chuckle when I see engineers produce these maps, not the most informative things. And you can improve those maps by doing things like maybe overlaying your state ortho photos. The problem in this case is it's for a road redesign project, and the area that people are really concerned about, which has some severe erosion with it, is located in an area where in the ortho photos from the existing base map for the state, there's some pretty extreme shadowing. So the nice thing about UAS is we can go out and gather higher resolution imagery with a high degree of accuracy. So here we're flying with an RTK-enabled system, so it's getting real-time kinetic GPS correction. So we're talking about within the horizontal plane, centimeter level accuracy, and it lines up really well with these contour data that were acquired by the surveyors. And it's going to take surveyors a number of days to go out and survey an area like this. So we can also produce these terrain products from UAS. And what we find with UAS is don't fire your surveyors, right? They're not a replacement with surveyors. But when you couple UAS with your survey crew, then you can go out and do some really accurate mapping. So have your surveyors focus on the really important parts, then integrate the UAS data to cover a much larger area, and you can save yourself a bunch of money. Okay, so once again, don't believe the hype about sort of UAS replacing everything that we do, and this could be whether it's generating topographic maps or doing bridge inspections. Think of it as a complementary technique to what you have that may help to reduce your costs and or provide additional information that you didn't have before. All right, so let's take a look at something else. This is an interesting thing. This is an airport survey here. All right, so this is an airport survey. Here we've got a runway. This is the Newport Airport in Vermont. All right, this is the original runway. This is the state ortho photos. The state went ahead and expanded the runway. Okay, so they lengthened it to allow larger aircraft to land. So an efficient way to update your aircraft plans is to go out and use UAS, right? We can gather updated imagery, higher resolution. We can even monitor the construction if we seek. But what was really useful in this case is because the runway was expanded, they needed to make sure that there was appropriate clearance between the surrounding forest and what's called the approach surface. The approach surface is the minimum altitude that a plane would take when landing on this runway. Okay, really important to make sure there's enough clearance with those trees. So going out and surveying all those trees manually would take an awful lot of time. But with a three-dimensional model from a UAS done with a simple camera and a fixed-wing flying system, we can get a really accurate map of that. And when we coupled it with some survey reference points to ensure that we know the level of accuracy that we're getting, it's a great product. And so here's a screen capture of a web map that we set up. That sort of cyan box there you see is the approach surface. Each one of those little tree icons there was the tree height automatically extracted from the digital surface model produced by the drone. And so now we've got a 3D environment that allows us to confirm that the airport is meeting FAA requirements, right? And instead of spending days upon days upon days doing field surveys out there, a combined UAS integrated survey operation can knock this down to really get it done in under a day. Same is true of areas, once again, that are accessible and hard to reach. We've got an area here in Vermont where severe erosion, FEMA buyout, they needed to get some site plans of the area. This is just a ground photo. We can gather ortho-rectified overhead imagery that provide us a comprehensive picture of this. And so when you're applying for your FEMA grants and you need to have evidence of what you have, and they want these site diagrams with contours and things like that, we can go ahead and get those really accurately with UAS, and then also do things that we do traditional in a 3D world, right? Do things like stream cross sections and all of that. All these technologies and analyses are exposed to us. We have done some fairly large projects. This is UMass Amherst. Large projects are challenging with drones on multiple levels. Limited battery life. Something like this where there's people walking around, we've got to fly in small sectors, we've got to notify people, you need spotters out there, you need to have notifications to the community, all of that stuff. So doing something on the order of sort of 1 to couple or maybe even a few thousand acres over a few days is kind of really the maximum that you're going to get coverage with drones. So the drones are not going to be mapping your county, okay? They're not going to be mapping the entirety of your interstate. They're good for these smaller projects, and I think flying sort of a college campus is about the maximum size you can get. But what's nice, of course, is you get this amazing, amazing detail, and you get quicker turnaround. So compared to the traditional aerial flights for these campuses, you know, we can turn around products for small areas in 12 hours. For larger areas, it may take a few days, but you're getting higher resolution for quicker turnaround. And you're getting a whole suite of products, right? Not only ortho photos, but the digital surface models and point clouds. And we can take all this stuff and then we can go ahead and, right, generate our GIS or CAD data from it. So some of the other things that we've been using it for, especially in disaster response, here we have a very localized flood that dumped a lot of sediment into these buildings here. Now, does this town know that it's flooded? Absolutely. There's people that live there. That's no secret, right? But when we want to provide verifiable information of where it was affected, having drone data that's accurate, that's orthorectified, that we can bring into our GIS so that we can map the areas of sediment, so we can overlay the property parcel boundaries, and then so we can highlight those property parcel boundaries through simple overlay methods, that's really the power of GIS there, right? Verifiable, integrated geospatial information, and doing this on a very quick turnaround. So the area gets flooded overnight, drone team comes in the next day, by the afternoon you've got imagery, and then within 24 hours in an event you've got a complete geospatial product. All right. So we've also, oh, hang on, folks. Looks like I suffered a technical issue here, flash crash. So I'm going to try to, which click meeting is on, so I'm going to try to reinitiate here. Are you guys folks still seeing my screen, or did things pause?
Yeah, no, your screen's gone right now.
Okay, we're trying to.
Well, Jarlath tried to reconnect there to his desktop. Anybody have any questions so far? I know I saw one.
I see we've got one in the chat session here, right?
Yep.
Do we think the federal government will change sort of drone flying in areas? Yeah, that's a really good question. You know, obviously there's a lot of, and this isn't about the legalities of flying drones, but I think when you have these big events, right, and people realize they need these data, it does push the FAA a bit more to consider how we're going to integrate drones into the airspace. Disaster response applications, especially like what we're seeing in Houston and Florida right now, are incredibly complex because there's so many other aircraft out there, right? And sometimes these localized disasters, so I think I'm back online now, the screen here is from one in Plainfield, Vermont, right? No one else is flying imagery of Plainfield, right? It's Plainfield and Barrie got flooded, the damage is in the six figures, it's very localized, there's not a lot of assets out there. But these big events that we have, I think it really does hopefully push the federal government to think, maybe we've got rules, but maybe we can have exceptions to those rules. And they do have policies right now to get sort of advanced and rapid turnaround on sometimes approvals for waivers and things like that for the existing regulations. So this was an interesting project where we had a long-term monitoring of this stream over time. They had consistent issues with woody debris coming down during flooding events and doing substantial damage to the bridge in town. So here's a pre-event image, and then here's a post-event image, right? And so the great thing about the orthorectified imagery we can get from UAS is the ability to do these before and after, right? We can get out there and fly at key times. I think even more important in this case was we had a section of stream where the engineers who were doing the bridge redesign really needed to know how much woody debris, how many of these trees out here that are in the streams are flowing through that bridge during one of these storms. Really difficult to do. If you're talking about a few miles of streams, especially this stream here, which has severe erosion, you can see all that, especially on the left side there. A real dangerous place to be doing field work, and also very, very slow and costly if you want to do it. So by going out there and gathering these before and after images, we can really map change at a very, very, very fine scale. So here we have that June 25th image, which is pre-event. The July 21st there is post-event. So this was a flood that came through about close to half a foot of rain overnight. You can see all that woody debris, that big clump of trees there went downstream. May have ended up at the bridge, may have gone through. And then you can see the evidence of new erosion along the stream bank there, so we've got stream stability issues. You can even see how some of the large rocks there moved around. So to get these insights, which would be very, very difficult to do using any other technology, right? Satellite images, even the best stuff out there, does not have this resolution. And we know that manned aircraft will be really costly in this case. So here's what you see in maps, sort of taking all of those things and just going through and having our undergrads digitize, we were able to come up with a woody debris budget by stream segment. So to look at the debris lost and debris gained during that storm, and really insightful information. And we're really excited, along with the engineers at Malone and McBroom and the Regional Planning Commission. This was selected for a National Transportation Award, right? Did the UAS help build the bridge? No. Did it save anyone's life? No. People's lives weren't in danger. But what it helped the town do is considering the possible bridge options, it really narrowed down the ones that could accommodate the type of extreme weather events that they're going to be facing in the future. And really that's the purpose of UAS, and to do it at a relatively low cost, right? So let's kind of wrap things up here and talk about some of sort of the benefits and limitations of UAS, right? So we know that it can be, in many cases, faster than traditional methods, right? Our ability to get out there and fly something around. And the cost savings can be substantial when we look at either traditional man-piloted aircraft for geospatial data acquisition, commercial satellite imagery, or just doing surveying alone, right, because of the amount of time out there. We know that it can be safer to get out there, especially in these cases where we have something like these eroded stream banks, and all that type of stuff, and the ability to access those difficult to reach areas. You know, there's always value in having the aerial perspective, or sometimes having the persistence up there. And I think we're all GIS people, so we know the value of not just having images, but geospatial ready data. And particularly nowadays, as we move from more 2D mapping to 3D mapping, the fact that we're getting 3D information from drones is pretty exciting. But we really need to be upfront about the limitations, right? These are tiny, tiny little things. They can't fly in rain. Legally, you're prohibited by flying at night, and you're not going to get good imagery at night. And high winds and rain are really going to impact your operations. You're not going to be flying. This is technology, right? So you can have equipment malfunctions. Lithium-ion batteries are very, very unreliable. We've seen high-profile cases with some cell phone manufacturers, no different with drones, right? A battery can explode, a battery can malfunction, it can tell you it's 50%, and then turns out there's a bad cell, and then it suddenly drops to 10%, and you've got to try to get it back to landing. So all sorts of things can happen with equipment malfunctions. That being said, our experience has been like products like the fixed-wing drones we're using from SenseFly are extraordinarily reliable systems, and also very safe, particularly if you're looking at something like a styrofoam fixed-wing, because when it loses power, it's going to glide to the ground. If you lose power from a large quadcopter, you can imagine a multi-rotor system with a LiDAR sensor, that thing's going to come crashing down and do some real damage. I think we still have a lot of issues with drones on the privacy and perception side. So fundamentally, what we're doing with our drones is aerial mapping, right? Google does it with airplanes. Microsoft does it with airplanes. States do it with their orthophotos. Federal government does it for orthophoto collection. Any location pretty much on the Earth's surface, there's multiple satellites acquiring imagery of that every single day. But there's something in people's minds about the drones, right? The idea of them being used for military purposes and surveillance. And we need to work on changing that narrative, right? So a mapping drone with a camera where it's taking pictures and you're not accessing that imagery until it's landed is very different than a drone that's up giving a live video feed, okay? One is a mapping system, one's a surveillance system. You know, we've mentioned that the batteries can be unreliable. They also don't last for very long, right? Until Tesla makes a awesome drone battery, you know, the fact is that most of our flights are probably going to be in the 20 to 60 minute range. And as a result, we're covering, you know, dozens to, you know, 100, maybe a couple hundred acres, but really that's it in a single flight. And then there does require expertise, and what we continually find in working with organizations is the expertise is not really on the drone side. There's certainly experience and value in having a good pilot, particularly with complex operations for drone flight operations, but it's dealing with the deluge of data, right? Sometimes you can go out and do these projects and you're producing a massive point cloud of 50 points per square meters and ortho photos and digital surface models, and maybe the people that you're trying to feed the information to are running a very old version of AutoCAD or a very old GIS software package, and they don't have the expertise to ingest these new, complex, very large data formats, okay? And many organizations we find, although they think about integrating drones, particularly in the transportation sector, oftentimes those organizations are ill-prepared to integrate drone data because it's very, very difficult. And this is particularly true on infrastructure inspection, right? If you think about traditional bridge inspection, maybe done using a paper or perhaps even electronic form, but what happens when you go out and every time you fly now, you're acquiring 5, 10, or 15 gigs of data, right? It requires the back-end IT infrastructure infrastructure. It requires people to understand how to use and work with these data. And I think that expertise and tech-savvy stuff and IT backbone is really the real challenge with drones. It's easy for us to fly. It's easy for us to produce vast amounts of data. It's not always easy to get massive amounts. So we'll take a look. I think we've got some other questions here, and then also mention that if you're going to the New York City GIS conference in October, Ben Houston is organizing a great session on drones there to better inform all of us, and then we'll be presenting there and get some other people. I see, yep, Ben has a question here. So with all the local government benefits, do you see local governments need to establish their own UAV programs? I think, right now, it's been my perception that a lot of local governments are reluctant to establish drone programs, and I simply think that's the case because they are worried about the privacy issues, and also there's expertise involved, right? It's just like a lot of local governments don't have surveyors. Maybe they have one or two people that do GIS, and often those people are planners. So do you want to have this team that's good at processing, orthorectification and filtering point clouds and things like that? My guess is that stuff will be probably contracted out. Where I do think local governments need to be aware is when they're putting contracts out there for work is to think about a geospatial clause, which says if you acquire geospatial data, we would like copies of that. And a lot of the times when we're working with engineering firms on helping them implement UAS into their operations, they're maybe doing a construction project, right? It's not a UAS project, they're doing a construction project, and they would like UAS imagery for compliance purposes, for volumetric measurements, all those types of things, right? So UAS are there helping the sort of contractor on the project, but I think local governments probably want to think about having clauses in those RFPs so when you're doing construction or surveying that those geospatial projects come back. Some other questions here. From an applied sensor perspective, when trade-offs between flight time and sensor weight, are multi-3 bands or even hyperspectral sensors currently available or being seriously pursued, IR, thermal, radar, etc.? Yeah, thanks so much for that question, John. I think it's really good. So I come back to the real advantage of drones, right? Lightweight, easily deployable, quick turnaround. And so we've gotten, in those of us that come from a satellite remote sensing background, right, we know that having a lot of additional spectral wavelengths, for example, on the Landsat satellite that has 30-meter resolution is extremely beneficial, right? But Landsat only hits the same part of the Earth's surface every 16 days, and it's really a moderate resolution sensor. Yeah, can you put hyperspectral and multispectral sensors on UAS? Absolutely, but keep in mind you're dealing with, as soon as you get into more complex sensors, you're adding weight. As soon as you add weight, you drain your battery. And quite often these other sensors, when you go to a fancier multispectral sensor, and we do use them on occasion, but their spatial resolution is not as good. And you don't really need spectral bands to find white pine, because you can, in 2-centimeter resolution imagery, you can just see if it's a white pine. There's other advantages in that if you're looking for things like invasive species, you probably don't need a multispectral sensor if you just know when those species green up compared to other ones. So just flying at the right time can be hugely advantageous. Now, as soon as you start going to active sensors like LiDAR and SAR, and then even some of the ones for longer wavelengths like thermal, you need a bigger sensor, and that's where you start going to a bigger drone. And this is where you run into the issues of how big do you go before your drone needs a catapult to launch, so you're not deployable, or a small runway. Or your drone now weighs 40 pounds, right? And if it falls from the sky and lands on someone's house, it's going to do some damage, right? If one of our 1.6-pound styrofoam wings lands on someone's house, they're not even going to know it's landed on their house. I mean, that's the big difference. So I think it's about figuring out, what's the best when, right? And if you take a look at LiDAR and drones, it can work very well in some situations. I think there's still a lot of situations out there where, quite honestly, a ground-based LiDAR sensor will get the job done for you more cheaply and more effectively. But I think there are some cases, and I know AirShark's been doing some really nice work on the LiDAR systems. But you can't map very large areas, right? We're talking very, very limited area for mapping the LiDAR data, and I think that's true with SAR. If you look at our thermal camera, we've got a drone with a thermal camera. But the thermal cameras, it's not the FLIR system that's on a Black Hawk helicopter, right? So it's severely degraded compared to other ones. It's important to keep in mind. Dave made a nice comment there about the highway department has added a drone for localized flooding, and we may see that. I think we'll see, probably people just getting their FAA licenses and maybe just having phantoms up to capture video and images. And then I think when you get into, are you using UAS for sort of generating engineering diagrams, right? I doubt you're going to see a situation in which the town's going to fly something, with RTK and a $20,000 drone and then pass that imagery off to the engineering consulting firm. So thanks for that, Dave. And then, someone put the New York City GIS Association conference dates in there, which is just awesome. So, happy to.
Yep, that's the New York State GIS Association conference. Will be in Lake Placid, October 17th through the 19th.
Not a bad place to be in October. Cool. So I aim for half an hour. Think I did it, but I'm happy to stay on for the rest of the hour if other folks have questions. Feel free to reach out after the fact. We've been working with a number of companies and state agencies throughout the region, helping them integrate UAS into their operations, doing things from the case studies and evaluation type things. But, Lawrence Armstrong said it's not about the bike. I mean, quite honestly, I have yet to find a situation where kind of like the drone was a limiting factor in it. It's always kind of like the back end stuff, like are you prepared for the data deluge that you can produce from these systems?
Well, thank you, Jarlath. And also, as people exit out of the webinar, there should be a survey, I believe, that will pop up, if you don't mind filling that out as you exit. Anybody have any other questions for Jarlath? All right. Well, thanks. And I'll probably leave the session open here just a little bit to make sure everybody has a chance to fill out the surveys, and then we'll shut it down.
Sounds great.
Thank you.